Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Okay, hello everyone, and welcome to the Building Science Podcast. I'm Kristof with Positive Energy, and today we're going to be talking about a very important topic, somewhat of a continuation of our previous one, and it's on the practical and philosophical motivations to shift our industry to a new way of delivering buildings. And we have a fantastic guest for you. We have Corey Squire, Sustainability Coordinator with Lake Flato. Go ahead and introduce yourself a little bit. Give us a sense of your background and what you're doing now.
All right. So my name is Corey Squire, Sustainability Coordinator at Lake Flato Architects, San Antonio, Texas. I've been at the firm for almost 3 years now. And often people ask what a sustainability coordinator does. Not every architecture firm has one. But I'm in and out of all the projects in the office. We meet with project teams, set sustainability goals, do a lot of simulation, daylight energy simulation, a lot of massing studies, a lot of kind of optimizing shading, optimizing fenestration, any sort of sustainability certifications. We can run through that process. And overall, just kind of keep the office on track with our sustainability goals. Make sure no project falls through the cracks.
Right. Good. Yeah. And I know that you've had the opportunity to instrument some of your buildings, and we'll be talking about that. You've learned a lot. That's
actually the big thing. Yeah. So a lot of times the project ends, the occupants move in, and then my job starts. And I kind of take it from there.
Exactly. And so just to get back to the overall point for you listeners, the overall point of this podcast is this idea that the design and delivery process that we are engaged in as project teams, as architects, engineers, builders, commissioning agents, whatever the role, the process is just shifting very gradually, and it needs to shift more quickly. And that's something we're going to be able to support today with some ideas from basically, actually, Corey, touching on what you've been doing when you measured buildings. Could you describe some of the things that you found when you instrumented a building after it's gone through your standard design process?
Well, all right. So I guess to start off, I'll mention what instrumenting a building kind of entails. So what we want to do is we have a design in mind. We have an idea of how the project's supposed to be working. But often we don't go back and see if the project is being used as designed, performing as designed. Architecture in general tends to not use this feedback loop, or at least in the past it hasn't, the way that a lot of other fields do. So we will come up with an idea. This space is great for daylighting because we're putting the window here and because the occupant uses the space this time of the day. But we never go back, or we rarely go back to see if our assumptions actually work out in reality. So what I've been doing in terms of, and what Lake Flato's been doing in terms of our post-occupancy, is measuring energy at a very, very granular level, measuring daylight with daylight meters. We'll put a grid on the floor, we'll walk through a space, we'll take measurements at different times of the day or different times of the year. And we're starting to move into the world of indoor air quality measurements and kind of that should hopefully lead into health and happiness and these kind of metrics. So we always talk about they're very difficult to measure.
Right. Mm-hmm. But they are ultimately what we're expected to deliver.
Ultimately, the most important thing is that is great architecture should make the occupants better off, and in a variety of ways, not just the way they experience the space visually, but their thermal comfort, their how they experience daylight, how they experience glare, what they're breathing in, what they're eating, how relaxed they are, right? So
yeah, 400 pounds of air a day on average. Each
400 pounds a day, yeah.
Yeah, so I think that's a really important point, and it can't be stressed enough that a building is in fact it's two things. It's architecture as the art, and that's, it's the sensory elements in terms of the aesthetic concept would be a line, shape, color, texture. All those get combined into a formal composition. I'm trying to talk like an architect, even though I'm an engineer. So if it sounds like
we can go over that in a second.
There you go. Yeah, but things like pattern, balance, symmetry, all those things. And then there's architecture as craft. And this is the piece that really we want to get into today. Architecture as craft, meaning something gets built, and that built thing has certain characteristics that either it does its function as intended or it doesn't do its function as intended. And what's happened, big picture, is that buildings now are expected to deliver on many, many dimensions, and to deliver very well in many dimensions at the same time. And so you not only have been instrumenting your buildings, learning that a new process is needed, but you've actually been engaging with consultants and trying to change the process, right?
Yeah. So I think one of the major lessons that we learned from monitoring the building, and this was just when we started in terms of energy, is our buildings are using more energy than we anticipated. And initially, when you're just reading utility bills, you don't know if the HVAC system is using more energy, if the occupants are setting their house to like 50 degrees over the summer. But because we were able to sub-meter and really get a granular idea of where the energy was going, our analysis showed us that we were doing a really good job in the areas that we were focusing on. Basically, it confirmed that we were experts in the areas where we already thought we were experts. But there are a lot of other areas where we just never thought about. The pool is an example. Lighting automation is an example. A lot of things that either we were not directly involved with their design because traditionally they're just handed off to a pool designer or a lighting designer or an HVAC design build. These parts of the project we're not performing to the same degree as the parts of the project that we're very, very closely focused on. And that makes perfect sense that we should be good at what we practice, what we're good at.
Right.
And we should find people who are great at these other areas. We should find a great pool designer to design our pool, a great lighting designer who really cares about the quality of the light and the energy use of the light. And when we've attempted to do things outside of our range of expertise, the outcomes have not been great.
Mm-hmm. Yeah, and there's other hurdles to delivering great buildings that are implicit in the industry. I mean, I'm just going to call a spade here. One of them is the first cost bias. It's really hard to get around it. That even on higher end projects, it's got a bigger budget, but there's more expectations for high end finish outs and things like that. It's hard to get away from not just first cost bias, but the bias that is implicit in there, which is, oh, I know what an air conditioning system, a heating system is. It looks like this. When in fact, it's been progressing over the years and it might be due for revisions. I'm thinking of things like variable refrigerant flow systems, and even we've talked about radiant heating and cooling systems. And then there's also that the products that are available in the United States are not, the palette of colors for a mechanical designer like me are restricted compared to other areas. I guess I'm trying to just lay the case here that there's definitely room for improvement, right? And I guess at the final end of it, it's almost blasphemous to say, but a fantastic design is really a partial solution, right? It needs to be an actual fantastic building. And, fantastic is doing what you're doing, quantifying the outcomes, quantifying the energy use, the light, the odors, sound, vibration, all those things. So tell me, what do you think is the future for the design process? Do you have a glimpse on how that might look?
I think the design process is going to broaden out. We talked about a minute ago all these new areas that architecture has to focus on. It has to focus on your visual experience. It has to focus on your auditory experience, your health, which is increasingly becoming more and more important. And because we're moving away from an art and moving towards a kind of really integrated and holistic vision of living and being, is like the Corbusier quote that a building is a machine for living. And I don't know if he intended the way that we're imagining this now, but today there's all these different factors, and all these different factors come with their own experts. And and a real team is required to bring these different perspectives and these different expertise to end up with a great building that really satisfies the needs, the biological needs, as well as the preferences of the occupants.
Mm-hmm. Exactly. And just going a level deeper there. So you talked about the process and all the experts. And by the way, this is reminding me of something. Maybe if we could do a little shout out for you and I are planning a workshop coming up. For those of you listening to this podcast before April 20th, there's a workshop on integrated project delivery and working with teams and getting into the core of it, which is the enclosure, the mechanicals, and the people.
Yeah, the event hosted by the San Antonio AIA, and we'll have a flyer and all the information up on the San Antonio AIA's website, hopefully today.
And so the point I wanted to dig into is we're going to have that workshop is going to be somewhat of a discussion group. And one of the areas of discussion is how do you integrate all these various perspectives and all these various expertise paths into a project when that's going to be unfamiliar to most people in the room. And it's also true that experts like to be experts. They don't like to, or maybe not don't like to isn't the right way to say it. They're not familiar with sitting in a place of, I guess, more open-mindedness and humility and trying to listen to the other experts and understand how what they're saying impacts what I need to do and how I need to think. That's a challenging part. And you've talked about this as the psychological aspect of putting together a functional team.
It's an interesting problem that you bring up. A lot of different fields, either architects or engineers or construction managers or site superintendents, they all have different backgrounds, different experiences, different education, and think in completely different ways. And one area we hope to explore on this upcoming workshop is how do we communicate with these people who are not just seeing the problem differently, but approaching the concept of the problem differently?
Exactly. It's a whole different tool they're trying to build. And the easy solution is the one that is the market mainstream right now. And that is somewhat to try to treat the project like it's a relay baton and hand it off from expert to expert. And each one does his or her magic to the baton and ultimately hands it back to the GC that then hands it to the trades. So this idea of
I think you imagine like a row of chefs working together, almost like an assembly line, right? And then there's this dish, and the first person does their thing, and the second person maybe does something else, and the third person does something. And then at the end, you have this thing that everybody had a hand in, but it's not necessarily as coordinated as it could be.
Exactly. Everybody needs to be on that first play. It's funny. That's an awesome metaphor. Go ahead, Corey.
Yeah, we should just get together at the beginning to discuss what we want the end to look like, and then do it again throughout the process. And then at the end, we'll all end up with something that we're happy with and proud of and have ownership in.
That's exactly right. You just triggered for me this idea of like, where is it that process where it's like the assembly line process has really worked, right? It works where, like in cars, where we produce the same vehicle over and over because there's lots of time and money spent up prototyping and engineering the first one. And then you can put it into a process like that. It works in fast food, right? That's actually what popped into my head is we're not making high-end custom home burgers here. You know, we really want these to be custom made and custom produced. And so I appreciate you triggered that. So we all need to get in at the front end and not just say, well, once this plate gets passed to me, I'll do my piece. We need to share responsibility at the front end. And there's another psychological aspect, and that this gets into, reminds me of Corbusier, the tool for living.
The machine for living.
Machine for living. There you go. Tool is my perspective on machine. But so we take building physics. Obviously, we're all interested in making sure the building doesn't fall down and that it lasts a long time. And recently that's being translated more and more, as you said, into the health aspects of it, the biological side of a building, which is that there are living beings in there and they're experiencing the indoor conditions very intimately. And then beyond that, there's the psychology of the people in the building that is actually now trying to be influenced by project teams like the ones you and I are lucky enough to be on, where we say, I want thermal comfort to be fantastic so that my client will actually experience a psychological support from being in my building.
And there's a phrase for this. It's architectural predeterminism. The idea that your space informs so much about your life, your mood, your feelings, your ideas. And I mean, some ideas about this that we've seen before are in hospitals, where it's been documented that recovery time is faster in rooms where there's a window to the outside. And you just extrapolate backwards to that as we spend some time in a hospital room occasionally in our lives, maybe, but we spend all of our time in our houses. And if you come home to a space which is full of light, which is inspirational, which impacts you in different ways to support kind of the lifestyle that you're hoping to have, you're going to be happier, you're going to be more productive, you're going to have better ideas, you're going to be more creative. So it's
not to mention your immune system will be supported and you'll be exposed to fewer pollutants, and over the long term, that'll almost certainly have big impacts.
Yeah.
Yeah.
So, but I mean, yeah, if you don't have good air in your house and you do get sick a lot, that interferes with what you'd like to be doing.
Yeah.
Right. You're not gonna get as much done. You're not gonna enjoy your experience as much. So yeah. I mean, it goes to all aspects of your life. How well you sleep, how well you get along,
your relationship with your neighbors, your partner, exactly. Yeah.
Relationship with your spouse, relationship with your neighbor. I don't know how many divorces are caused by interior environment of their home, but there's totally an impact there.
Yeah, and I think that's actually almost a key point, Corey, because I know you and I are both. If there was like a bell curve for the way buildings are delivered and the way the buildings function, our goal is to be out there on the leading edge of how it's done and how they end up being. But there's people more in the mainstream, and I talk to them a lot, and there's a lot of discipline and exertion going on by these people. They're not just lazy, careless people, but they ultimately think that, all these incremental improvements don't really matter. It's just a little nudge and it's not going to lead to radical transformation. But it's actually that's not the case. These little incremental improvements in air quality, light quality, sound, as you're saying, energy use, of course, durability, they're
vibration that you brought up too.
Yep, vibration. Yeah. We're being very careful how we hang our indoor units in your buildings. But yeah, so it does matter. And you got the food metaphor in my head. So this idea of it's not like when I was a kid that we didn't have beef, chicken, eggs, milk, and spinach. But think about going shopping for those things today, right? You can have grass-fed beef and farm-raised chicken and, oh my gosh, milk, hundreds of different varieties, organic spinach. And you could say, oh, these are all little things. Maybe it tastes a little different. But you know what? We as a society are getting more and more discriminating, more and more, selective in what we eat and how we eat. And so we've made this shift. And you and I know that, our clients like nice stuff. They're making really careful choices about their eating. And they would want to make the same choices. They would want us to make more so. They would want us to make on their behalf the same choices for their buildings. So things like in buildings, dedicated dehumidification and ventilation, you could say, oh, it's just a little shift. It's imperceptible. But if you apply it over, what is it? There's 130 million homes in this country, and how many billions of breaths are taken each day in those, and trillions of tons of air or something. Over all of those, there's going to be societal level impacts. Maybe our healthcare system's not burdened as much. And okay, so that was definitely off on a philosophical angle. Now, you mentioned that the factors that determine a good building were broader than you thought, and you mentioned expanding the scope when it comes to approaching about a building project.
Yeah. So what we were able to do by measuring the energy end uses of projects was to see where buildings use energy and compare that to where we thought buildings use energy. And also compare that to where our clients thought buildings use energy. So one great example, we received the utility bills of a project that's using more energy than we expected, but we used top of the line systems. We used what we thought would be great strategies. There was no obvious reason that the building was using more energy than it should have been. Spoke to the clients. Clients were very energy conscious people. They talked about unplugging their toaster when they weren't using it. They talked about unplugging other appliances in their house. So from our perspective as architects, when the building's using more energy, it's obviously the HVAC system, because what we've kind of been trained to understand is that the biggest energy user of a building is heating and cooling and ventilation.
Hot water.
Yeah, all those major systems. And our job as architects is to shade windows, decrease the size of windows, build better envelopes, to try to support these systems to use less energy. The client, the occupant's perspective was all these things that they plug into the walls. The mechanical systems were so background that it wasn't even obvious to them that was the major energy users. But toasters, but ovens, things like that, things that they had this physical relationship with the electricity of plugging it in or unplugging it. So that's where they thought the energy was used. And when they noticed the energy use was larger than they expected, they spent more effort unplugging things, right? So it wasn't until we actually measured this house where we learned number one energy user was the pool. And this is something that was on neither of our radar. The pool's outside the house. It's not considered traditionally part of the architect's scope, really getting into the details of the mechanical system behind the pool. It's also not really part of the engineer's scope. I mean, there are pool designers and there are engineering principles to pump water through filters, but it was not on our radar. And it was using more than 50% of the energy for the house. And it's not that all pools have to use that much energy, but this pool is programmed to run 24 hours a day, 7 days a week on a high setting. The pump, the filter, it wasn't pool heat, which is what a lot of people think when I tell the story. It's all the filter. It's pumping water through pipes, through a filter, back into the pool. Now, pools do use a lot of energy, even efficient pools. But you could run a pool pump on about 4 hours a day, 5 hours a day. All you need to do is make sure that algae is not growing. So whatever filtration level is required to prevent algae. But the incentive of the pool installer is not to use as little energy as possible. The incentive is to not get a callback. That person never wants to have algae in the pool. So there's zero chance of algae growing in the pool if the pool is running all the time, if the filter is constantly running. There's probably 0% chance at 12 hours a day. But we can just make sure by running it 24 hours a day.
Yeah, absolutely. 0.00.
Right. So, if you want it to be as efficient as possible, what you would do is do some experimenting. Run the pool 6 hours a day for a week. See how it looks. If there's no algae, try 5 hours a day. And you can ratchet this down and get the optimal pool schedule. And if you do this, the pool actually it will use a significant amount of energy. It'll be a major appliance in the house, but it's not overwhelming. It's not 50%. It's not even 25%.
Yeah. Right. That's fascinating. And it's very important for people to take that away, that it's the operation of many of these big machines, these big energy users, that's as important as the machine itself. But as you said, it's not to discount that there are different ways to deliver heat to pools, and that does have impact. There's different ways to filter. There's different purification technologies. But the one that's my kind of pet peeve is looking at how many 90-degree bends are in a typical pool installation, knowing that every 90-degree bend is resisting the flow of water that the pump has to provide, and that the pump works harder. There's just no way around it. And touching back on mechanicals, air conditioning and heating systems, I just was out walking my dog yesterday, and there's a big, really high-end house in my neighborhood going in, and no one was there. So I walked in, took a look around. First thing I see is ducts pushed in to the joists, the trusses, the roof truss system. And then after that happened, somebody did spray foam insulation on the roof deck. And as the spray foam insulation expanded, it completely crushed many of these ducts, right? So not only are they replacing insulation with ducting, which is a big no-no, but what they've done is in the pool metaphor was you put a lot of 90-degree turns. It means a lot more resistance to flow, and you're going to get the flow. So that means you're going to run, the pump's going to work harder to do it. Same thing on mechanical systems. Air distribution systems, they are usually the least attention is given to the air distribution system. People will say, oh, am I using this type of equipment or this manufacturer or this system? Well, you know what? If you had to think about it clearly, it would be better to put all your money into the air distribution system because you can change out the sources over the years. But instead, it's like you buy a Prius, which is a nice engine and all that, but your Prius, the tires are going to be deflated, or at least half deflated for the life of the car. Right? That's a bad air distribution system in a house. I want to take you back, actually. So you were talking about the misaligned, I guess that's the way to say it, the misaligned interests of the pool installer.
Well, yeah, let's broaden that out a little bit. So we had a mechanical installer on the team. It wasn't a MEP, but we had sustainability goals. We had energy use goals as a lead for homes project. So we had to hit certain targets. We had a green rater. We had all these people. We discussed how the building should perform. And we discussed the hot water system. We discussed the heating and cooling. We discussed ventilation. We looked at lighting. But who wasn't at the table? The pool installer wasn't at the table. And the pool installer was never part of the team. And we never thought that the pool installer should be part of the team. It just never crossed anyone's mind. It didn't cross my mind, anybody else's mind. But while we were having that conversation, us and our consultants, about the energy use of the project, the pool installer, whose energy actually affected more than 50% of the entire project, was out doing his own thing with no idea that we even had energy goals for the project at all. So that kind of goes back to the original argument of kind of broadening the scope of what a house is. So we extend the boundaries of energy use, not just to the house and not just to the systems that we understand, but to the property, to the energy delivered to the site, and how everything's going to be used. And I mean, Kristof makes a great point with the 90-degree angles. But you can have broad sweeps as much as you want if the pool's going to be running 24 hours a day.
Oh, absolutely.
Running 24 hours a day. So we were discussing last week this idea of conservation versus efficiency. And a lot of the emphasis of sustainability and in our profession is on efficiency, when in reality it should be placed on conservation. So the difference between those two things is efficiency is how you take a system and produce the same outcome using less energy. It's kind of the broad idea. Conservation is just how you use less energy. So I can trade in my Subaru Impreza for a Tesla, and it's a more efficient car, and I could use less energy going to work every day. Or I could take my bicycle, which doesn't use any energy. It's efficiency is usually the more expensive way of getting somewhere, and it's usually not as effective as just taking your bicycle, switching off your pool pump, all these things that are often overlooked because they're not as technical as maybe the more efficient solution.
Well, now don't forget, someone had to feed you energy. So there's a whole distribution system to grow, distribute, and deliver food to you so that you can have energy to ride your bike.
It's true. Yes. I said it takes no energy. It does take significant energy to bike to work.
Yeah. Are you downhill or you live uphill?
I am downhill on the way to work, but I am uphill on the way home.
There you go.
And there's still fossil fuels involved with the fertilizer, unless everything is entirely organic. So yes, there's a broad way of looking at all these things, and we can calculate everything out.
And that's what's happening, man, is that, like, why are we doing this, right? Why are you and I engaged in integrated process delivery? It's partly because we have expanded, we have broadened our understanding of the impact of these buildings, and we don't see just there's an electric wire coming in. We see behind the electric wire trains full of coal. And I mean, seriously, that's what's there, right? And the water supply, oh my gosh, so much energy implicit in water, and water shortages. And so we need to understand that it's not do-goodery. It's not like we've sinned against the earth and we now need to do atonement, which unfortunately there is that sort of sense out there in the industry. It's just that this matters. We need to make good decisions. We make good decisions all the time. I love that you triggered the food idea, right? So we make good decisions. We're making different decisions in food, from the 1950s and 60s when the food industry will feed us and then the medical industry will heal us.
If we're going back to the 50s and 60s, we could think about the fact that 150 years ago, we didn't have air conditioning. We didn't have a lot of these systems that provide us with comfort. So a lot of these ideas were kind of passively integrated in. With food, there was a much more kind of natural way of feeding our bodies, of growing our food. Our houses were designed in a way that better partnered with natural systems. And then we invented all these machines to do all these things, and we kind of decided we don't need to think about these things anymore. The machines can do it for us. And recently, we're kind of switching back and kind of remembering what we knew as a society 100, 200 years ago. And we have the machines still, but now the idea is how to work best with the machines and nature kind of in harmony.
I love it. Yeah. And so the ultimate harmony that is the first ingredient that we need to put into our projects is this expanded team, this broadened team, like who's in the room. It brings up a couple things for me. One is you can't have, or it doesn't seem useful to have everyone in the room for every meeting. So there's got to be some continuity and there's got to be some judgment used, to define who's there when. And I have two questions for you. One is, I know you've used this term sharing risks and sharing rewards. Could you expand on that a little bit?
Yeah, so it's a little bit of a concept that hasn't really been put into practice in a real meaningful way. But you can have a team, and you can have the leader of the team who defines the scope for everybody else on the team. And you can meet more often, and you can be on the same page in terms of goals and process. But a truly integrated team is going to have to see a little bit of a breakdown of traditional scopes. So, and that leads into kind of much broader things like fee structure, like responsibilities for different areas, for even how the team is structured. So let's go back to the pool installer example. And we can bring the pool installer kind of into the meetings. We can discuss our total energy use goals for the project. That person can be on board. That person can try their best to make the pool as energy efficient as possible. But the real team, it probably needs to. Let me think of a good way of describing this. When you kind of give people the ownership over the project. So instead of just kind of being handed a piece and on the same page, if you're fully integrated as part of the team and the successes of the project reflect on you in all areas and the failures of the project reflect on you, that's kind of how in the future we could get to a point where we have this kind of pure, thorough, integrated design team concept. I'm probably not describing it as amazingly as possible.
No, but I hear you. And I want to give an example. So
go for it.
The example would be today is Monday morning. What is today? The 28th or something of March. Yeah. And so we're on some projects as a team with builders and architects. And so we got a call this morning or an email about a decorative fireplace that's unvented in a home, and what did we think of that? And they wanted us to they want another separate one was we switched from LVLs to trusses everywhere. Could you see what the impact would be on the air distribution? Would that help you or hurt you? And roof color was also what came up. And I'm only using these as these are the 3 Monday morning calls we got from teams that we're on. And what's different is, we're a building science consulting shop, an MEP shop, a human factored building design shop. But when we're on the team and we know we're on the team, we don't have to get that call and say, okay, put me on retainer, or let me get you a proposal to answer that question. We can just answer that question because we understand that our role is broadly to support the outcomes that the team wants. And the various project teams that we're on, they understand that too. That positive energy is there to answer a range of questions across a range of issues. Whereas before they would say, okay, so my MEP guy is just talking to me about these systems and really the technical aspects of it. But you actually touched on something. You said the leadership of the team is going to be the one that defines the scope for everything. So, we've talked about the need for change. We've talked about what we can do about it, how we need to better integrate. But there's this one question, and who is it that takes the lead? Who do you see as that's a prime actor on taking the lead for integrated project delivery? Is it
Do we need a leader?
Is it the owner, the developer, the builder, the architect, the homeowner?
We can act like ants. We don't even need a leader. We just all know what to do.
E.O. Wilson would love it. The building just got built. No one led. No, but seriously, who do you think takes the lead? Who do you see?
Traditionally, it's the architect, and I imagine the architect is still the one who's gonna take the lead on the project, because what we do interacts with what everyone else does, and what everyone else does interact with each other, but probably not to the same degree. So it's the rare owner that would really want to be involved to the level. It's not going to be an owner. I mean, I don't know if we want it to be the owner. But I mean, we want the owner. We want an OPR. We want to know exactly what the owner wants and what the owner expects out of the process at the end. But yeah, it makes sense the architect leads the team, but the architect surrounds themselves. Imagine the architect being the president, and the architect surrounds himself with a cabinet of experts in diverse fields, and doesn't ask people when they become Secretary of State or Secretary of Treasury to propose a scope and a fee, but more, we have a lot of issues and we have a lot of experts in a lot of different issues. Let's all get together and discuss them. We have a cabinet meeting. Yep. So it could be something along those lines.
Right. I like it. Yeah. That's all I was trying to get clear on. And I agree with you completely. It's the architect is in that central position, and they should be. And the architect is in the process. I mean, architecture education hopefully is in the process of expanding. I mentioned early in the podcast this idea of architecture as art and architecture as craft. And we've hired architects here, and I know that they come out of school very well familiar with architecture as art. The things we were talking about earlier: contrast, proportion, theme, symmetry, balance, all those terms. It's also true that there's a technical side to a building. There's an actual technical elements, and there's what does the building do, right? It connects to all these societal level services of water, electric, and gas, and infrastructure. And it also delivers healthy, safe, comfortable spaces. So, architecture is poised to adopt this integrated, holistic view that we've been discussing on this program. Our basic point here is that we should be using integrated processes to deliver buildings. We should think progressively, and by that I mean we should want our delivery process to progress and to change. And you mentioned about this ethical prerogative when we were talking earlier. Do you want to discuss that?
Yeah, well, so, and I think this is something that you, Kristof, have brought up in the past, where there is an ethical prerogative to provide our clients with all these features to benefit their lives, things that they might not even know that they are without or that they desire. So thermal comfort and the intricacies describing thermal comfort are not kind of in the layperson's vocabulary. But everyone knows when they're uncomfortable, and it's our responsibility to make people comfortable.
Right, absolutely.
And that's true for thermal conditions, for auditory conditions, for olfactory conditions. Mm-hmm. And we do have an ethical prerogative to create spaces that benefit the organism kind of the occupant.
The biology, yeah. Yeah, I wholeheartedly, man, I'm high-fiving you on that. And not just that, but it's that one of the reasons we have that ethical prerogative is because the assumption on the part of our owners and developers is that we are paying attention to all these things, right? They have fancy gadgets in their pockets. They have cars that are just getting more and more refined and performance oriented. And there's the assumption that the buildings are too. And often buildings are advancing visually. This is a little bit of a slippery slope, but often I see that a building is just blowing me away, drop dead, amazing, gorgeous, impressive. And then I open the mechanical closet and there's the 1970s alive and well, because no one thought to, it's similar to your pool. No one really thought to say, well, we should deliver an actual design as opposed to whoever the builder or the GC hired, whatever they decided to do, that's what got done. So it needs to be integrated. Mm-hmm.
Yeah. So the ethical prerogative, I mean, it's probably not an ethical prerogative to work as an integrated design team the way they were describing, though it would be nice. But we do want to cover all these bases. And what I think and what Kristof thinks and what a lot of people are coming to is that kind of integrated process with a lot of experts focusing on their field, but also interacting with other experts. That's how we cover all these bases. That's how we create these spaces that are comfortable, enjoyable, productive, happy, all these great things. So this might be the best venue for meeting this ethical prerogative that we have about creating this whole holistic environment for the occupants.
Mm-hmm. I hear you. Yeah. And it's not just prerogative in the sense that it's the architect's decision to make, and it's architects need. It's a bit of an ethical imperative in some sense, in the sense that it matters. It ultimately matters to everyone involved, and for the life of that building, it will matter.
All right. So the conclusion of all of this is, or I guess the next step for all of this, is that these teams that we're describing, the architect, the MEP, lighting designers, pool designers, they're a teeny fraction of all the houses that are designed. And of all the people who live in houses, only a teeny fraction of them live in houses that were designed by architects, and a smaller percentage of houses that are designed by a variety of experts. So what we need to do is figure out, once we can figure out how to make this process work at this high-end scale, but then how do we move these concepts into kind of the rest of the built environment? And that's something that hopefully we'll be able to work on and figure out as time goes on.
Absolutely. That is a fantastic place to leave us questioning. And it's also true that it'll happen somewhat naturally because we have a market economy, and that airbags entered automobiles in high-end, luxury automobiles, and now they're ubiquitous. And cell phones were usually the domain of the super rich, and now they're spreading. So once fantastic buildings, once we have the ability to deliver them, and we have the process, it's going to expand.
And we have the means to measure them.
And yes, the measured performance that you guys are doing, it's fantastic, and it's brave, and it's absolutely the market leadership that we need from you. Thank you so much, Corey. Okay, that's it. We're out. Join us again next time for the Building Science Podcast. I'm Kristof Irwin. Thank you very much.